Humans have been using aerodynamic forces for thousands of years with sailboats and windmills. Important concepts in aerodynamics, continuum and drag, appear in the work of Aristotle. Although observations of some aerodynamic effects, such as wind resistance, were recorded by Aristotle, Leonardo da Vinci and Galileo Galilei, very little effort was made to develop a rigorous quantitative theory of airflow prior to the 17th century. In 1505, Leonardo da Vinci wrote the Codex of the Flight of Birds, one of the earliest works on aerodynamics. He notes for the first time that the center of gravity of a flying bird does not coincide with its center of pressure, and he describes the construction of an ornithopter with flapping wings similar to a bird. Isaac Newton was the first person to develop the theory of air resistance, making him one of the first aerodynamicists. After that, many scientists helped to develop concepts of aerodynamics. Nowadays, we can see giant aircraft like Boeing 747 that can contain more than 400 people crossing the sky. That's amazing. The first plane was created by Clément Ader on October 9, in 1890 to take off and fly 50 meters. The Brazilian Santos Dumont was the first man to take off abroad on airplane. In 1914, the American pilot Tony Janus made the first commercial flight in history. Aerodynamics is the study of the movement of air and other gases. Aerodynamics includes the study of the interactions of air with moving objects, such as airplanes, and of the effects of moving air on stationary objects such as buildings. The two primary forces in aerodynamics are lift and drag. The lift refers to the force elevating the airplane. For example, airplane wings are designed so that their movement through the air creates an area of low pressure above the wing and an area of high pressure underneath it. The pressure differences produces the lift needed for flight. The principle is known as the Bernoulli principle. Drag forces are parallel and opposite to the object's direction of motion and are caused largely by friction. Large wings can create a significant amount of lift, but they do so with the expense of generating a great deal of drag. That are extended on airplane wings upon the vehicle's landing exploit this trade-off by making the wings capable of high lift even at low speeds.
That sounds amazing. Aerodynamics only used in aircraft industry?
No, there are many different areas for which knowledge about aerodynamics is useful. Aerodynamics has also been used to develop rockets, helicopters, and even the current Formula 1 car. I'm going to explain this with a Formula 1 example. Teams invest up to 20% of their total budget in the examination of the influence of drag on the car. They observe the behavior of cars in wind tunnels. By using innovative aerodynamic knowledge, they can design even faster cars. This way, precision work is undertaken down to the last millimeter, according to the motto, races are won in the wind tunnel and lost on the track. Biggest teams of the Formula One employ more than 400 engineers, and aerodynamics is possibly one of the most important points in order to win races. In order to develop the car aerodynamics, teams spend an average of about 50 million bucks to build a wind tunnel at their factories. Of equipment that separates the big budget teams at the front of the grid from the small budget teams at the back of the grid. As with airplane wind tunnels, the car wind tunnel is a massive tube joined at each end and with fans producing airflow. From an operating room beside the tunnel, a team's aerodynamics engineers monitor a model of the Formula One car and study the computer signals that define the way it reacts.
You ready? Let's go!